In this video on coordinate geometry of the line, we're going to be looking at our formulae. So we'll need to have our log tables to hand. If you open up page 18 of your log tables, you'll see it looks like this. It starts off with a diagram, which just shows a coordinate plane with 2 points P and Q marked on it. And then there's a list of formulae directly below. We'll be using the first 4 formulae on this page, which are slope, length, midpoint, and equation. We'll be starting with the formula for length. This is sometimes called the formula for distance. So since we're starting with length, I've written that formula on my page, and it's a really good plan that whenever you're using any particular formula from coordinate geometry or any area in maths, write the formula that you're going to use down on your page before you begin. Just a word about the notation before we begin. So you'll see in the diagram they provided in the log tables that the 2 points in question are labelled P and Q, and that's the reason why they're using P and Q here in the name for the distance. You can also see that they've called P x1, y1 and Q x2, y2. That just means that they're taking P to be the first point, so the first x and the first y, and Q to be the second point, the second x and the second y. The 2 straight lines here around the P and the Q refer to size. This type of notation is used fairly regularly in maths to talk about size, and in this context, it's the size of the line that joins P and Q. So that's how long that line is, or the distance between the points P and Q. And looking at our formula, we can see we've got a square root symbol that goes the whole way over the entire formula. It's really important to do that right the way to the end. And in the first bracket, we've got x2 minus x1 squared plus y2 minus y1 squared. And every part of this formula is important. But in good news, we'll be able to use our calculator to help us out with it. Okay, so let's look at an example. So in my example, I have 2 points, A and B. A is the point 22 and B is the point 65, and I want to find AB, and this just means the distance of AB, or the length of the line segment that joins A to B. Before I begin to fill the formula in, I'm going to start by labelling my 2 points. I'm going to think of A as being the first point, so I'm going to call it x1, y1, and I'm going to think of B as being the second point, so I'm going to call it x2, y2. And now that I've done my labelling, it's really quite straightforward to take these numbers and put them in the right places in the formula. So I'm going to write down the name of what it is that I'm looking for first of all. So I'm looking for the length from A to B, and then I'll begin to assemble the formula. I'll start off with a nice big long square root, and if you need to extend it as you go along, that's totally fine. And then I can see in the formula that I want to put in x2 into a bracket. So in this case, my x2 is 6. Then I want to minus x1. x1 is 2. So I'll minus 2. And then the bracket closes after the x1. But there's a little square symbol, so I'll put that in. And then next I've got a plus. And then I can see that I've got another set of brackets with y2 minus y1 this time. So in this case, that's 5 minus 2. And again, that bracket's being squared. Make absolutely sure not to forget those squares, otherwise you won't get the right answer. And then at this stage, I'll go to my calculator and I'll type into my calculator exactly what I've written down here. So I'll start off with my square root, and then I'll open bracket 6 minus 2, close the bracket, hit the squared button, plus open bracket 5 minus 2, close bracket, hit the square. And you can see how the square root continues automatically along the top of the calculator screen. And then I'll press equals, and my answer is 5. And that's the distance between A and B. So this one worked out as a nice, neat whole number of 5, but don't forget that won't always happen. It won't always come out quite as neatly as that. So let's look at a second example for what happens if we don't get a whole number answer. So example 2. So this time I've got the point C, which is 1, 3, and the point D, which is 3, 4, and I want to find CD, and again that just means the distance between C and D, or the length of the line segment that joins them. So like before, I'll begin by labelling my points. So I'm going to call C the point x1, y1, and D the point x2, y2. And then I'll write down CD to indicate this is what I'm about to find. And then I'll begin to fill in the formula. And again, I've got the formula in front of me here. I should have the log tables to hand as well to make sure that I'm filling it in correctly. So again, let's have a look. It's x2 minus x1 underneath my square root first of all. And I must make sure not to forget the square. Got a plus in the middle. And then next I'm going to have y2 minus y1. And again, don't forget the square. So again, I can type this directly into my calculator exactly as I see it. Don't leave anything out. So I'm going to say the square root bracket 3 minus 1, close bracket, squared, plus, open bracket, 4 minus 3, close bracket, squared. My answer comes out this time as root 5. I could use my calculator to change this into a decimal if I wanted to, but generally when we're dealing with coordinate geometry, if we get an answer of this type, we tend to leave it as the root. This is called leaving the answer in surd form, and a surd is just any number that contains a root somewhere along the way. The reason that we tend to leave our answer in surd form if it pops out like this is for accuracy. Root 5 is an exact value, but if I write this in decimal form, I'm going to be forced to round it off. And as a result, I'll lose a little bit of accuracy along the way. Of course, as always, in some questions, they might specifically require you to give your answer to a certain number of decimal places. And if that's the case, that's totally fine. But otherwise, feel free to stop at surd form. That's the form that we'd like to have our answer in. Okay, so here's a question for you now. So E is the point 23 and F is the point 46, and I want you to find the distance from E to F. Pause the video here, complete the question, and then play and see if you're correct. So I've just made sure my formula is visible to me first of all. I've labelled my 2 points. EF will be equal to the square root of 4 minus 2 squared, because that's x2 minus x1 squared, plus 6 minus 3 squared, because that's y2 minus y1 squared. I'll type this straight into my calculator, and I'll get an answer of root 13. And I'll leave my answer like this in surd form. Let's look at another example. So in this example, I've got 2 points, G and H. G is minus 1, 2, and H is 3 minus 4, and I want to find the length of the line segment that joins them, or the distance from G to H. So at this stage, I think we all know how to begin. You're going to label your points. So take a moment to do that. Let's make sure we've got our formula to refer to. And then let's begin to find GH. So I'll start off with my square root as usual, and then I'll begin to fill into my formula. So x2 minus x1, so that's 3. Now, be careful here because this x1 is a negative number. Notice that there's already a negative in my formula. I'll need to write in the negative from the formula and the negative from the number. So my calculation will look like this. 3 minus minus 1 squared. That's the minus from the formula. That's the minus just belonging to the minus 1. After a bit of practice with these, and if you're being very careful, you could just write a plus in straight at this stage. But just to note that your calculator can also cope with the double minus. Let's continue so with the calculation. Our plus goes in next. And then we have our y2 minus y1. y2 is negative, that's fine. Minus y1. No double negative this time, so we'll just write it in as minus 4 minus 2 squared. Off to the calculator now, and you can choose to either write in 3 minus minus 1 or 3 plus 1. And your calculator will give you the answer as 2 root 13. And again, this is an example of a surd. And we're quite happy to leave our answer in surd form, and we should do unless we're instructed otherwise.